The intention for this demonstration is to display the ways that Mathcad and Pro-E can work together in simulations. Not necessarily the results of simulations, but doing iterative type simulation work based on changing design conditions. So what we go through when we do this is that we evaluate a certain scenario and we have a payload sitting on a tray, and what we're going to do is we're going to determine the strength of the lifting lugs on the end of the slings that are coming down. That's our ultimate goal in this demonstration. Now the video clip is showing some display items that we're going to be using going forward in this simulation. So take note of these. These will be some changing values that we'll be coming back to later. These include the weight of the object, the tray, which doesn't change weight, and the payload, which will change weight. So we're adding some parameters to the model tree so we can easily witness the effects of change on the current conditions. So as you can see, currently the payload weighs about 5,500 pounds and the tray statically weighs 1,500 pounds. Things that are going to be fluctuating are going to be the overall weight of the unit and the sling load. So we have some relations that pulls out tray as the mass of one component and payload 2 as the mass of the payload sitting up there. So now we're looking at the payload and how we change the mass of the payload. Now we're going to quickly activate the model to make a change. We're going to change the mass of the payload, and what we're going to do is we're going to change the wall from a 2-inch thick wall to a 3-inch thick wall. This will have an associated weight change of the payload, of the overall load, and of the load that each sling sees. So now Pro-E is going through the mass properties of all the items and editing those values. We saw that the payload went from 5,500 pounds to 7,780 pounds. So at this point we're going to open up the Mathcad side of the bidirectional tools. And we're going to show the feature inside Pro-E that payload 2 and tray are input parameters to the Mathcad, and the output parameter from Mathcad is a variable we've named load sling. All of the units match up, payloads in pounds, the weight of the tray in pounds, and the output of the load sling is in pounds mass. So we're letting it recalculate the output value, which is the parameter called sling. We'll open up the Mathcad file and see how the input values, tray and payload 2, are being passed to Mathcad. And we're looking at the coincidental data, weight of the tray, payload, total weight. Then through trigonometry, we get the vertical load, and through known sling angles, the value load underscore sling is calculated. So now we go into the simulate application, and we're going to look at the idealized masses that are applied on the simplified rep. We remove the payload, since you don't want to mesh the payload. We don't need to do anything about it. We just need the effects of it and that it's connected back to the tray model through its footprint on the tray. So payload 2 now has a weight of 7,778 pounds nominally. So now we're going back to standard Pro-E from the simulation application. Constantly we're generating and reevaluating mass properties to make sure everything is updated. Go back to simulate, and we're going to look at the definition of the load in the model as defined as 2,675 pounds. That's along the axis. That's the value of sling as defined by the output of the Mathcad file. So the load is a symbolic value called sling, and it's getting its magnitude from the relations to the Mathcad. Sling in the model is load sling in Mathcad. This is the main focus of the interactivity between the programs, the ability to link parameters. So now we're going to go back and look at another adjustment being made to the payload. And we're going to do the adjustment by going back to the standard mode and activating the payload part. Now we're going to physically change the size of the payload, take off a few inches here and there. The logic behind is that the mass will decrease. We already made one change, we increased the wall, but now we're going to change it again. These are arbitrary changes. It's regenerating the shape of the model, and we're going to update the graphics and the simplified reps. Go back to the master temporarily to make sure it's all fully regenerated. Then we're going to go to the mass properties again and force the assembly to calculate mass properties. Generating the report, we see that we have a new total weight and new value of payload 2, which is the mass of the rectangular block. We're going to go back to the simplified rep FEA1, and we're going to look at the simulate. And then we're going to look at the masses that are defined. And you can see that the mass of the tray is unchanged. The total mass of the payload now is 6,389 pounds, which is down from the 7,780 pounds. And the sling load is also changed because Mathcad has determined, based on the input of payload 2, a new sling force was calculated, and we're now prepared to run another iteration of the analysis.